We will now explore how Rust has made strong design choices for safer arithmetic expressions. So the first one is called an integer trap. So let's see the C program first. So in this case, the right hand side is C code and the left hand side is Rust code. So the C code performs a very simple arithmetic division 5 by 2 and the result expected is 2.5. 5 by 2 is 2.5 and the same result is being printed. Now let's see if C will print 2.5. So if you see, the result is only 2.0 and not 2.5. Why is that? That is because here both the operands 5 and 2 both are integers. So C performs only integer division and the fractional part 0.5 is discarded. And this is called an integer trap. So, and also, right, like C does even implicit conversions. It silently converts from one type to another type. So, all this can be so much problematic because, compiler, if it is trying to compile and silently change from one operand type to another operand type, it can cause lot of unexpected results, right? And there is here in this case there is loss of precision. Zero point 0.5 is already lost, and these kind of bugs are very hard to find. The reason is, like this is a very small part but lot of arithmetics are used, like in calibrations, right? So assuming a very simple thing, right, like assuming we have a health monitoring temperature system. Okay, so if the temperature of the human body is 100.5 or above, assume that an alarm or an alert needs to be raised and specific medication can be given. It's just an example. So in this case, if there is a loss of precision like 0.5, like instead of 100.5, if it is giving us 100, then the alert is gone, right? So similarly, in case of calibrations, audio calibrations or any kind of hardware calibrations, if the precision is lost, then that can result in low data quality, right? So what does, and these are very hard to find. This logic looks so correct, right? But however, this is not giving us. So if you want in kind of C, in case of C, if you want to have 2.5, either we typecast it to floating point or we can just use 5.0, means make it floating point here so that it prints 2.5. See, now it printed 2.5. So this is not very obvious. This is not obvious, right? And unless we have 100% of unit test cases for every logic written, these bugs are very hard to find. If this is a part of a large algorithm and the result is used to calculate calibration or any other complex, hashing or checksum or random numbers or anything like that, then it can be a problem, right? So in case of Rust, what happens? Let's check now only the Rust program. So this is Rust code. The same thing is applied here. In Rust code, there is a variable binding called result and it's of type float 32 and these two are integers. 5 is an integer and 2 is an integer. Let us see if this code, what does Rust do? What difference has Rust made in this? See, in case of Rust, this gives an error. It simply doesn't compile at all. It says, hey, the result is F32, but found integer. You convert this into F32. Okay. So what does it expect? The first design choice, the first strong design choice it made is to make sure that both the operands should be of same type. 5 and 2 should be of same type. So how do? We simply use a keyword called F32 and here also as F32. Or simple words, you can simply make it as 5.0 and 2.0. So because it gave a compilation error, the programmer is forced to think, hey, what went wrong here? Right? So the best code reviewer in our case is the compiler. Now this compiled, let us run the program. The result is 2.5. So in case of C it was not obvious, but in case of Rust it simply doesn't compile at all. Okay, so what are the advantages of this? So this prevents accidental conversions, right? It prevents accidental conversions. Rust simply rejects the code and it encourages programmers to think about data types. It improves readability, right? It improves readability. Okay, so basically the rule is the design choices. Rust wants both the operands to be of same type to prevent unexpected results, and every conversion should be visible. Okay.